Hi, my name is Luke and I'll be showing you the shell method today. Now, shell method is basically an application of using integration. Now, you learn that when you're integrating a curve, you're finding the area underneath that curve. But when you're using shell method, you're actually finding the volume of that curve when it's rotated about a certain axis. Now, there's one equation you need to memorize for shell method, and it's really easy. It's just that area is equal to 2 pi times radius times the height. That's it. Now let me give you an example. So for example 1, you have a curve given by this equation. Y is equal to the quantity of x minus 1 times the quantity of x minus 3 squared, and it's bounded by the x-axis. And x is equal to 1 and x is equal to 3. Now you're asked to rotate this curve about the y-axis and find the volume of that solid. Now just to illustrate this curve, when you graph it on your graphing calculator or in computer application, this curve will look like this. Just the it's like a bell bounded by the x-axis, and x is equal to 1, x is equal to 3. Now when you rotate it about the y-axis, it'll become a solid. It will look like a pot of some sort. In fact, I have a figure of that too. It will look like this. Okay. Now to approach the shelf method, it's important to have this 3D this rotated figure in mind, and then draw these cylindrical sheets around the figure, like such, like this figure right here. You have the curve right there, and then when it's rotated, it will look like this. And then what you're doing is drawing an infinite amount of these cylindrical sheets around the curves, starting with x is equal to 1 to x is equal to 3. Now, your first step is to try to find an equation for the area of a single sheet, and that's the equation I mentioned earlier. A is equal to 2 pi radius times the height. This will get you the area of a single sheet. Now let's do it for this problem. Now you can probably tell the radius will be some value x from here to here, x, and the height is from there to there. It's some value. It's a function of x, but it's y. Now I just want to clear it up on the height right here. The height is the y value of this curve, which is described by this equation right here. So let's write all that down. A is equal to 2 pi times the radius, which I mentioned is x, times the y. And you can expand that out. For y, you have the x minus 1 times x minus 3 squared. Now that's the equation for a single sheet. That's the generic equation for the single sheet. Now what you want to do is to integrate this area from x is equal to 1 to x is equal to 3. This will get you the volume of this figure. So volume is equal to integrate from x is equal to 1, x is equal to 3 of this equation. 2 pi x minus 1